That image is.
All right, shut up! All right. So, like as I said, this is for the Ann Arbor people, I guess. That I heard the assignment was too easy, so we'll make the next one harder. I mean, how much time did we spend on this assignment? Only 5 hours? Anybody,
He did say it would take 12.
did anybody spend over 5 hours?
Is this just on the assignments we're reading also?
Well, I don't know. What was the assignment, first of all?
1.15 and 1.16 exercises. So basically 15 and 16 from the first chapter.
1.15. All right, so let's go over these. What part of shut up do we not get? I'm going to go over the homework here. All right, so duple. This guy returns a list containing n copies of x. So for instance, if I have duple 2, 3, I should get a list containing 2 3s in it. Duple 4 of ha-ha should give me a 4 list with 4 ha-has in it, right? Okay, so one of the things I want us to focus on with this stuff is patterns of solutions, because you're going to start seeing that pretty quickly. What we are doing gets repeated very often. All right, so I'm going to start with a couple of kind of warm-up things here, where what if I want to go through a list? Because really what we're doing here is we're saying, I want to go through and I want to do something each time through the list. And the second one was 1.16, invert. Okay, so invert says where a list is a list of 2 lists, go through each element of the list and invert that list, right? Okay, so this first one is we're going to go through and we're going to be counting down a number. So n starts at 2, we want to do something. Then we want to do it, then the 2 becomes a 1. Then the 1 becomes a 0. And we want to keep doing something until that thing goes down to 0. So we're counting down. And what do we want to do each time? We want to be working on building a list. How do we build lists?
Construct in the pen.
Cons. So cons constructs a list. So we'll go ahead and I'm up here, right? So we're going to define a variable named duple. And duple is actually a function. So how do we represent functions in Scheme? Lambda. So we're going to have lambda, and this guy is going to take an n and a list, or what did the book say? They call it differently. N and x. Okay. So those are our parameters. So we want to make a list containing whatever x is n times, right? So if equals n0, if I've counted down all the way and I no longer have any more things to do, we have to take into account how cons works. If I want to build a list, if I want to build the list 1, 2, 3, I can cons 1 on the cons of 2 onto the cons of 3 onto the empty list. Right? So if n is equal to 0, I'm going to boil down to the empty list. Else, what am I going to do? I am going to cons whatever x is onto whatever's returned by duple for minus n1, so 1 smaller than n, and go ahead and pass on the other guy. So if I run this, duple 2, 3 gives me the list containing 2 3s. Duple, what was the other one? 4, haha, something like that. Gives me the list. And some of you saw this syntax that Blaine pointed out, this associates this little placeholder with this thing that takes up more space. So this is going to be a for list with 4 of these placeholders in it, where each one of those is actually the list. Haha. This is the correct answer. This is just a shorthand for showing it in case this guy is equal to some crazy thing that has a whole bunch of things. Yeah.
So you're able to interject like operators into functions then? How you have a minus there?
What?
Like you have the minus and what do you call it? Oh.
No, this is saying n minus 1.
He's talking about the minus 1 minus thing.
This isn't a me thing. That's not a me thing.
I was talking about the n minus 1.
No, duple takes 2 parameters.
Yeah.
It takes an n and it takes an x. Here's the value of the first parameter I'm passing it.
Oh.
It's n minus 1. So if n was 3, I'm passing it a 2.
Oh,
If n was a 2, I'm passing it a 1. So on and so forth. All right, so let's trace. So first of all, that looked a little bit easier than your experience. Okay, so let's walk through. So remember, well, one of our goals today is to think about this idea of patterns. All right, so in this case, I am counting down. I am doing something some number of times. How am I controlling that? I'm asking the question. As soon as I get down to 0, that means I'm done. What does I'm done mean for this particular problem? In this case, the problem I'm solving is a cons. I'm constructing a list. So my final move upon my death is to spit out the empty list so that the final string of conses is finally done. Okay, so if we kind of walk through this up here, and I pretend like my input is 2 and 3, so I'm calling duple of 2, 3. What's going to happen here the first time? So n is 2, x is 3. I'm going to ask the question, is 2 equal to 0? It is not. So I will not do the true statement. Instead, I'll do the false statement. What does the false statement say to do? It says cons a 3, whatever x is equal to, onto the call to duple on 2 minus 1. So this is minus 2, 1. And a 3. All right, so that's what I'm consing together. I'm consing a 3 onto whatever is returned by that call to duple, where I've counted down. So now we need to execute this call to duple. This call to duple, so 2 minus 1 is 1. So really, this guy becomes a 1. That's that call to duple. We ask the question, is 1 equal to 0? It is not. So what am I actually consing on? I am consing a 3 onto the duple of 1 minus 1, which will be a 0, and 3. Next time through, n is 0. Is n equal to 0? It is. And what do we boil down to? The empty list. So the output of that guy right there is the empty list. So what does this produce? This produces the list containing a 3. So that's what this guy is. It's the list containing a 3. And what does this guy produce? He produces the list containing a 3 and a 3. Because I'm consing a 3 onto the list that already has a 3 in it. And that's my final output. The 2 list with 3s. That make sense? All right, so that's how duple works. But forget about what we're actually doing. What does duple really say? What are we practicing with this? We're practicing the pattern of doing something a number of times. Whatever that something is. In this case, the number of times is n. So I'm counting down towards 0. That's going to be a pretty common pattern for us. Okay? Then what happens when I'm done? What's my special move that I do upon my death? If you're building lists, maybe that special move will be to die with the empty list. So it kind of finally finishes our final call to cons here in this case. Okay? Maybe it'll be return a 0 if you're summing up a bunch of things. Make sense? So whatever you do at the end, this is our controlled by recursion. Whatever we do at the end, that'll be this little death move here. And then if we are still working, okay, we're still counting down what is it that we should be performing each time. In this case, I'm constructing a list. How do I construct lists? I use this tool called cons. I'm going to cons the element that I'm supposed to be putting onto the list, whatever that is. Don't overthink it. X could be a 3, it could be the list it could be almost anything. X is a variable that holds a value. I am consing whatever that value is onto my list in progress. Okay? X could even be a lambda, where I'm just producing a list of lambdas. So I could say something like duple 3, and then I can say lambda x, y plus x, y. And I get a 3 list, 3 functions, where each of those functions takes 2 parameters and does something with them, adds them together. So my output here is 3 functions in a list. What am I supposed to do with that? Well, I can go through that list and take each of those 3 functions and apply them to 2 parameters. Can I? So can I say define result to be that? So now result is going to be a list with 3 functions in it, right? And here, just to we'll leave it at x and y. That's fine. All right. So when I'm done here, I will have a 3 list, and that 3 list will be filled up with 3 identical functions. And for each of those functions, if I pass it 2 variables, it'll add them together. So what I can do is define test funcs to be a lambda that takes in we'll call this guy a list of funcs. Okay, so it's going to be a lambda, takes a single parameter. We're going to call it a list of funcs. And what are we going to do with this guy? We're going to go through every element of the list, which happens to be our other pattern for the second question, right? Mm-hmm. Second question says, here's a list, go through every element of the list and do something to it. Mm-hmm. What am I doing? I'm going to go through every element of this list. It's only scary because we've put functions up on this pedestal and say, those are terrifying. It's just a value. Right here, duple. This is just a variable. I just happen to associate it with this terrifying thing that's going to haunt our dreams. But it's just a function. What do functions do? This particular function takes 2 inputs and it does something. All he needs is 2 bits of information. It's not like we're giving him all of our lifeblood. Giving him part of it. Part of our lifeblood. All right. Okay, so test func, our little idea here is that we're going to pass this guy a collection of functions. And in this particular case, I'm going to assume I know that these functions all take 2 parameters, and I'm just going to give it like 5 and 7 or something like that as parameters. Okay, so I'm going to do something like, and then maybe we'll add them together. Let's do 5 and 1, so the math is easy. So that gives me 6, and 6 plus 6 is 18?
Yes.
Right? Okay, so my result here should be 18. If I sum up the result of calling each function on the 2 parameters 5 and 1. Just randomly passing 5 and 1 in for x and y. All right, so what am I going to do here? I'm going to ask the question, if null list of funcs, small right there. If that's the case, boil down to 0. I'm summing up some stuff. I'm done summing, so I'm going to toss out a 0 so my math finishes. Otherwise, what am I going to do? I'm going to add. What am I going to add? I'm going to add the result of applying the first function to 2 parameters. How do I get the first function from my list of funcs? Car. I get the first element of a list using car. So I'll say car list of funcs. That will be a function. I'm going to apply that function to a 5 and a 1. So that's going to be my function applied to a 5 and 1. And what does that function do? It just adds those 2 guys together. So this is ultimately going to boil down to a 6. And what am I going to add that to? I'm going to add it to test funcs of the coder of list of funcs. And then I'm going to say test funcs, and I'll pass it result here. And there's my 18. Easy peasy, right?
I mean, yes, but actually no.
All right, go ahead, B.
So is it the list of funcs that they assume that you're gonna pass in the list?
Well, I'm assuming it in this case.
Okay.
So result, that's what result looks like. Result is going to be, in this case, 3 elements, where each element is a function that takes 2 parameters. Notice it renamed my function to take A1, A2. We're seeing how it internally stores lambdas. Doesn't matter, it takes 2 parameters. Okay, so this is going to be a list containing 3 lambdas. I just happen to know because in my stupid little example here, I used duple to create 3 of those guys. Now, what is that guy? He's a function that takes 2 parameters and he adds them together. If I give it 5 and 1, he gives me a 6. 3 and 2, he gives me a 5. 0 and 1, he gives me a 1. That's all that function does. Takes 2 inputs, adds them together, boils down the result. I just happen to have a collection of 3 identical functions. I didn't do anything fancy here. I just leveraged my duple to pull this off. All right. So what am I doing with test funcs? I'm just giving you an example of, hey, if you happen to have a list of functions and you want to call that list, you want to go through every function in that list and pass it the appropriate parameters, and for some strange reason you want to add the results all together, this is the code that does it. All right, so I'm feeding this guy my result, which is my 3 list of lambdas. So this guy takes in, I could have called this guy LOL or something. I just happened to name it something that was a little meaningful to what this variable holds. List of funcs is going to be a list of functions. In my case, I'm passing it a 3 list of identical functions where each function takes 2 parameters and adds the result together, adds them together, boiling down to the result. Each time through, I'm going to ask a question. Am I out of stuff in my list? Is my list empty? Is it the null list? I could also ask if the length of the list is 0. Could have done that too. But I'm saying, basically, I'm guarding here. I'm saying, can I call car on this list? Because if I have the empty list, car will break. You can't get the first element of a list with no elements in it. Make sense? So I'm saying, does my list have at least one thing in it? If no, boil down to 0. Why? Because I'm summing a bunch of things here, and I know adding 0 to anything won't change the result. It won't break my sum. That's why I chose 0 as the last thing I did upon my death. See that pattern here? Very often, as we're finally dying, our dying wish is to do one final thing that just happens to connect to our last recursive call. Otherwise, if I could call car, if I had something to do, what am I going to do? Well, I'm going to take the car of my list of funcs. Now, in this particular case, because I know the kind of value that I passed here, which is why I named the parameter list of funcs. List of funcs probably means I have a list of functions. The car of list of funcs is going to be what kind of animal? Cat, dog, or function?
Function.
Function. It's going to be a function. And this particular function is going to take how many parameters?
2.
2. How do we know that?
Because
That's how we wrote it,
yeah.
right? We called duple and we passed it a bunch of functions that take 2 parameters, just actually the same function multiple times. All right? So car here, what I have highlighted, will boil down to a lambda expression. That's a function. And that function takes how many parameters? 2. How many parameters have I given it? 2. Very uninteresting. I just always give it 5 and 1 just because I don't want to deal with too big of numbers because I can't do math very well. So I figured I can add 6 together 3 times. I can pull that off. I'm getting old, but I can do that one. All right, so I'm saying here is the function. He takes 2 parameters. I'm going to give him 2 parameters. What will this guy boil down to? What I have highlighted right there will ultimately boil down to what?
6.
6. Just a number. Why? Because the car is that guy. If I were to pass in a 5 for x and a 1 for y, and this guy boils down to those 2 numbers added together, this whole thing will boil down to a 6 when applied to the inputs 5 and 1. So all of this scary crap here boils down to the number 6. And what am I doing with that number 6? I'm adding it. Addition, extremely scary. Okay, so I'm adding 6 to something else. What am I adding it to? Well, because recursion seems to be something that's going to happen in our future a lot, I'm going to call test funcs again because I'm a glutton for punishment, right? So we're going to call test funcs again, but this time I'm going to call it on a little bit less of my list than I called it on this time. That is everything but the car of our list. Make sense? So now, the second time I'm calling it on a list containing 2 lambdas instead of the 3 I had before, because I already burned my first one and used it here. So I'm going to add my 6 onto whatever test funcs returns on now my 2 list of lambdas. So the second time it'll boil down to a 6 plus whatever my test funcs returns on my 1 list of lambdas, which will be a 6 plus whatever my test funcs returns on the empty list. And what will my test funcs return for the empty list? A 0. So those will be a 6 plus a 6 plus a 6 plus a 0, which is 18. And that's what we got here. If I change this guy to be 30, now you'll see the real value of those -1 things. And I just type in result here. We got a whole bunch of them. We got 30 functions in there. Very uninteresting and very, very, very similar functions. Extremely similar, so similar they're identical. But then we call test funcs on this. We should get 6 times 30, which is 180. Make sense? Go ahead.
Do you have something related to the local and global?
Yes, but you don't want me to answer that question yet because it'll allow me to give you harder homework assignments. something we're moving towards here is something called environment passing interpreters, where we're going to be passing our, well, right now. So I'll answer the first part of it, which only clarifies what we've been doing already. N and X are local variables to this function, right? I happen to not change X. With duple, I'm just passing X along each time. Like, look, this is the guy you should be duplicating. This is the guy you should be duplicating. But N, I'm changing them. Variables are allowed to be changed. We don't have to change them, but I'm changing N. So both of these guys would be local variables that live and die with this particular lambda. Make sense? But now, result here, this is a global variable to, well, from line 7 on. So I'm able to come down here on line 16 and I can call test funcs, which is a global, well, it's a variable that lives in the context of my little text editor here, as well as result, which is a variable that lives within my little text editor here. So I can put those guys together. So local is local to the current environment, where the current environment for result and text func is everything from line 7 on, where the current environment for N and X is lives and dies with this lambda. That make sense?
I have a question. So what if you take the lambda and then you put the result? Is it a list of funds? Would that do anything?
What do you want me to do?
So then you already define result, right? But
Yeah.
then what if define test funds and then lambda is a list of funds, you put in result right there?
I put result here?
No, like the
Where do you want it?
line number 10.
So you want to put result here?
Yeah, would that do anything?
Well, it will give me a local variable called result, which will shadow this guy, because with a lambda, this is the parameter list. I'm not passing result in there. I'm taking this will create a local variable within this lambda that is named result.
So it's not gonna, so the result above not gonna affect at all?
Correct.
Okay.
But you wouldn't want to do this, because result here is not a meaningful parameter. It doesn't really tell you, it's like, hey, here's a function, just pass me a result. Doesn't really give us much information about what we're trying to do. Yeah.
Kind of playing off of that, would you be able to, is it possible to do something similar to what you can do in Python, where you can have default values on parameters?
I think the answer is yes. I don't know if I've done it.
Okay.
But I think these are bad questions, but any little fuel you give me to ask you harder questions is going to be dangerous. No, I mean, the thing is that don't try to turn scheme into something it's not. Why did we choose scheme for this class? Did I choose it to torture you?
Well, partly.
No.
When I'm doing it up here, doesn't it look pretty simple?
Yeah.
Okay, so that must mean it's relatively simple. You're just new to it. What was the real reason I chose scheme?
To build a programming language out of it.
Okay, and why is scheme a good choice for that?
You're given almost nothing.
Because it's very logical.
It's little. The whole language is, from our perspective, we know how to create variables, we know how to ask questions, we know how to do repetition, and we really only know like 5 functions. It's a simple little language, which is almost the problem, right? You know, we go all the way back to 200, we have to solve problems in terms of the tools we have in our toolbox. I've given you a tiny little toolbox. It's like, go, solve these problems. And it's demoralizing, it's scary, it makes you feel stupid, especially Luke.
Yes.
Wow, you don't even deny it.
All right, so now don't worry about this too much right now. I mainly did this to kind of prove the point of this, the whole patterns thing, but also to really drive home this idea of, if you go back to like 200, and we talk about it's very important when we're reading code to resolve a variable, understand what value we're dealing with. Values can be all sorts of things, including functions. And that doesn't make them any more scary than something else. Just like pointers. Pointers aren't scary unless you're intimidated by hexadecimal numbers, right? A pointer means it points to a place in memory. That's the kind of value you're dealing with. A lambda means, lambda sounds cryptic just as it is, right? What does it mean? It's an unnamed function. Functions have 0 or more parameters and hopefully do something. That's what a function does, right? You go to your algebra classes and stuff like that, you know, and the teacher starts referencing functions. You get the f of x stuff. That's just a function call. You've been doing this for years, way before you learned how to program. You give it a value for x, you spit it through the whole thing, it gives you a number. The harder the math class you're in, sometimes it gives you number or gives you results in terms of variables, right? Start taking integrals and derivatives and things like that, and all of a sudden it's like, okay, well, the result was another function. It's a function that spits out a function. And I can give new inputs to that function and do some stuff with it. This isn't new. I've just repackaged it. We're connecting some dots with stuff you've already been doing. All right? But a list of functions is weird. Kind of knocks us off kilter a little bit. Okay? Especially the Ann Arbor people. Because they haven't had to deal with a character like me probably ever. Right? All right. So don't worry too much about this test function thing right now. If this is a little bit cryptic to you, that's okay. It should be. I think one thing you're going to notice over the first several assignments is you become less and less intimidated, but I'm going to be giving you new patterns. So the same thing, like today we've basically looked at 2 patterns, right? The pattern of counting, doing something some number of times, and the pattern of going through everything in a list in order from beginning to end. Those are 2 patterns we now have in our toolbox. So I'll be showing you I'll be asking you to figure out new patterns, and I'll be showing you those patterns after you've suffered. It's kind of my MO. All right, so what was the other question? Invert, where list is a list of 2 lists. So a 2 list is a list that has 2 elements in it. So this is a list of lists where each list has 2 elements in it. And what am I supposed to do with it? I'm supposed to I'm just supposed to invert them. So A1 becomes 1A, so on and so forth. Okay. So come down here. We'll define, was it just called invert?
Yep.
Okay, so invert is going to be a lambda. It's going to take here, I'm going to call it list of 2 lists. Will be real specific. Okay, that's what this guy does. He takes a list of 2 lists. I'm pretty sure you can have a number in there. I think so. You'll scream at us if we can't. All right, and what am I going to do? I'm doing the pattern of going through every element of that list. That's what I'm doing. So we're going to ask the question, if null list of, I immediately regret this, list of 2 lists. If I'm done, now, am I building a list as my result? I'm building a list that is the that is the contents of the original list inverted. So when I'm building a list and I finally got to the end, I'm probably going to return an empty list because I'm probably dealing with conses. So my pattern will be, I've run out of things in my list. Better not call car on that list again, otherwise Scheme is going to be very unhappy with me. So I'll just say, I'm done. Here's an empty list. Hopefully cons finishes with the right stuff in it. All right. Else, if I'm not dealing with the empty list, what am I going to do? Well, I'm building a list, so I'm going to con something. And what am I going to cons? Well, I need to figure out, how do I invert that 2 list? Okay. Well, you can do this a couple different ways. Doing the things that we've done so far in class. See, I haven't shown you the list function yet, right?
It was in the book.
In the book?
Yeah.
Okay, so we can create a list out of the catter of, let's see, we need to get the first element of the list. So I have the car of list of 2 lists. That's going to be my first 2 list, right? and I want the car of that guy. So I'm going to have the car of the car, or if you don't want to have to deal with those things yet, I want the car of that guy. So the car of list of 2 lists will be a 2 list. The car of that will be at the first element of that list of 2 lists. So it'll be like the A. Was it just A1 or was it like 1A? Yeah. So the car of the car will give me like the A here. All right. So I'm going to create a list containing that guy, but I want him to now become my second element. So I want the first element of this guy to be, well, I'm going to have the car of my list of 2 elements. That's going to give me the 2 list. Now I want the cooter of that guy, and then I want the car of that guy. Kick this down for a second here. Actually, let's do it this way. So the car of list of 2 lists will give me a 2 list. I want the first element of the new list that I'm building. I want that guy to be the second element of that 2 list. So I'm going to need the cooter of that car. So if I have the list A1, what is the cooter of the list A1? It is the list 1. Because cooter always gives me a list. So then I want the car of that guy. Let me show you what I mean here. If this is A1, for example, and this guy is in a larger list, ... This guy right here gives me that. This guy right here gives me the list containing that. The car here gives me just the 1. Make sense? And I'm going to create a list out of that 1 and, well, here's my car of that guy, which is give me that, and I want the car of that. Which will give me the A. So I'm going to create a list where the second element of my 2 list is the first element of my new list, and the first element of my 2 list is the second element of my new list. And I'm going to cons that onto something else. What is the something else I'm consing it onto? I'm consing it onto another call to invert, passing it the rest of my list, which is the cooter of list of 2 lists.
That's gonna take a while to get used to.
And then if we want to steal this, is this copyable? I'm concerned that that single quote might copy funny. Yep. Nailed it. All right, so this should create a bunch of inverted lists.
I had a question about the output. Does it put list in there for any specific reason? I know it's just saying there's a list, but why
Yeah.
does it put all the lists in?
It just denotes it as a list.
Okay.
Yeah. There might be a version of language where it doesn't show it like that, where it shows it with just the quotes.
Yeah, is there a way to prevent it from doing all those inserts?
I think, what do you mean prevent it from doing it? You mean the -1 things?
Yeah.
Yeah, I think somebody said that there is.
Jack found it.
Yeah. I mean, I don't know if it's that important.
Maybe I just
If there's placeholders, it's not like As long as you know how to read it, it makes it actually easier to read.
I suppose that's true, yeah.
Because otherwise you're going to have parenthesis diarrhea.
I just thought it might be, I just thought it might be kind of weird if you have like multiple numbers, like for the output.
Do you want me to really tick you off here with? Let me show you a little trick for this one.
Yeah, sure.
Remember, when I show you tricks, that means I can now ask that in the future.
Well, I just want to know more. Like,
Why don't you ask outside of class, Luke, so he doesn't give it more to us?
give us more tools.
All right, so obviously this is a pretty easy solution, right? There's a lot of stuff there, but we've already seen this pattern, right? This pattern says, go through every element of this list and do something to it. Though something we're doing to it right now is a little bit, complex looking with all the cars and the cooters and that kind of stuff. All right. Now, we do have a function called reverse. Yeah, so I think I can say reverse A1 like that, and it'll give me the list 1A. You could have written that. Doesn't matter. I mean, that's effectively what this is, right? Isn't this the function reverse?
Yeah.
That's what that guy does. So if I rewrite invert, that way you have the original one here. We'll call this guy invert 2. Really, what I'm doing is I am, steal that there. I'm consing the reverse of list of 2 lists onto invert 2 of the cooter of list of 2 lists. Now keep in mind, this isn't any easier. Reverse here is just a synonym for a function that we could have written ourselves. It's a function that takes a 2 list and reverses it. And how do we write that? It's basically that guy right there. We just wrote it. So let's define invert 3. Okay, invert 3 will be a lambda that takes a list of 2 lists.
What does map do?
I remember, I tried to figure that out.
What does map do?
Tell us.
You did just do invert. You didn't do invert 3, so it's just calling the first one.
Oh, sorry. It'll still work.
Oh.
See, that's the whole second question, was just that. So map allows you to apply a function to every element of a list. So I have a list of 2 lists. I want to have reverse applied to each element of that. For all intents and purposes, for you right now, it only works for functions that take 1 parameter. Just so happens that the reverse function takes a single list as a parameter and reverses that list. I'm not encouraging you to use map yet. I really want you to practice with the cars and cooters. In fact, I really would say the best solution for you right now is this first one. Go ahead.
map takes or applies it to a list, or can it apply?
Second parameter of map has to be a list,
Alright. What's the first parameter?
a function.
Oh, duh.
Okay. So 3 different versions of invert. They all should make pretty good sense, but trace through them by hand, make sure you understand it. But what I really want you to get out of today's lecture is the idea of patterns. Okay, because it's going to be pretty common that we're going to have to do something some number of times like we did with Duple. It's going to be pretty common that we're going to want to go through every element of a list and do something to that element of the list. That's what invert was. Make sense? All right, so let's see. We want harder homework for the next one. So we'll do down 1.17. It wraps parentheses. Okay, that's easy enough. Swapper returns a list the same as slist, but with all occurrences of S1. Oh. Notice that these are only the 1-star problems. The 2-star ones mean harder.
Oh,
The
really?
3-star ones mean nightmare. Drop out of school level stuff. So we'll be doing those over the weekend. Yeah. So homework for, what day is today? Wednesday? Homework for Friday is 1.17, 1.18. So the next 2 questions. So be very similar to what we did today.
Where would we read for that?
I mean, where would you read from that?
Like, where would we read to figure out, like,
Watch today's lecture.
oh, so we have all tools then?
Yeah, you have all the tools for the whole class already. You already know the entire scheme language. You don't have to use map ever. You could just write your own. You don't have to use reverse like we did today. You could have written your own reverse.
With cutter and car.
Yeah, it's easy stuff. You can just accomplish everything with cars and cutters and Kansas. Right? So this homework assignment should take you anywhere between 5 minutes and a day. And then I'll come back to class on Friday and solve it in 3 minutes. And I just get so much joy out of watching V's reaction. So, what's up? Yep. Remember, tonight is the first Tech Talk, 6 p.m. in the Collaboratorium Makerspace. V got food. There's going to be lobster tails, peel and eat shrimp. We're grilling burgers and I think we have like cookies and stuff. So you might want to eat beforehand or plan on eating afterwards, but light refreshments. But there will be opportunity for networking at the very beginning. So you can go up and introduce yourself to the speaker. You might want to bring your resume if you're interested in an internship or possibly a full-time job or something like that. Mike will collect resumes, and I'll meet with him afterwards to tell him which of you are worth talking to and which of you are a waste of time. But take advantage of it. Talk to your classmates. Talk to people from the business school. Talk to community members who might show up. What?
Well, I invite the whole companies to go.
Good.
So I'd send out to the product owners and then software developers in the building.
All right, I'll see everybody tonight. What did I say? 1.1718?